all technology has to be looked at carefully, but we need to exploit its advantages. And I do think AI will make things better.
Hello, everyone. My name is Stephen Parton, and you're listening to the Feedback Loop on Singularity Radio. This week, my guest is Rama Chellappa, a pioneering AI researcher and distinguished professor at John Hopkins University, who recently published his book, Can We Trust AI? In this episode, we attempt to tackle the question posed by Rama's book from many different angles, exploring topics such as the transparency of AI in regards to the black box issue, the accountability issues for when programmers create algorithms that end lives, the reliability of self-driving cars to navigate an ever-changing environment, and much, much more. Ultimately, Rama puts forth an argument that is certainly hard to counter. In essence, in a world of chaos where things will go wrong and nothing is perfect, are we currently holding AI to a standard that goes above what we even ask of our human peers? And are we being too preemptive in our judgment of AI, not yet realizing that we are still in the early stages of development? So let's go ahead and jump into these topics and explore these questions more deeply. Everyone, please welcome to the Feedback Loop, Rama Chellappa. All right, Rama. Well, I know that just in the last few days, actually, your recent book, Can We Trust AI, came out. And I'm wondering to start if you can just tell us about the motivation to write that book.
Yeah. I first took a class on AI in spring 1978 when I was a graduate student at Purdue. In those days, AI was still a fashionable thing to do. Established fields like pattern recognition and image processing were there. And AI, as you know, it had its origins in 1956 meeting at Dartmouth. Interestingly, by 1978 itself, this was kind of in AI winter because we had gone through the first round of rule-based systems and so on, and AI didn't deliver what people thought it could do, and then it had some issues. So we were all learning it like a course, a graduate course, but very fascinated. In those days, we were interested in theorem proving, playing games. Everybody thought AI means you can play better checkers with the computer or backgammon or chess and all of that. The idea of smart cars and things like that we have seen in TV series. The talking car. Not many kids these days know about that. There was a show. Yes,
Knight Rider, right?
Yeah,
Yep.
exactly. I always tell people, what? A talking car. So anyway, then I took another class in spring 1970. So I've been involved in AI, but I'm more on a special topic called computer vision because computer vision was still in its nascent form. And by 1980s, when it became more formal. So I've been involved in this, and I've seen the ups and downs. Uncertainty reasoning came into AI in the mid 80s. Since 2012, a lot of data-driven methods have become popular in AI, as they're known as deep learning, based methods. So before we were big on domain knowledge and all that. Now we are big on data. Of course, there's data everywhere. But then along with that, there are concerns about AI. Of course, there are all these Hollywood movies that show how a robot will come and take over your house, your neighborhood, your country, and all that. So there are lots of things like that. So I thought I should. Of course, some of the questions are in terms of, do we know it will work everywhere? Is it robust enough? There are issues. It may make some wrong decisions to certain subgroups of people and other concerns. So I thought I'll write a book that kind of intertwines my work, in three areas, and along with addressing some of the other issues and potentially how AI can be helpful. So it's a qualitative affirmative, right? Can we trust AI? So I thought I will write a book, and then Johns Hopkins University Press was very helpful, and my co-author Eric Miller was extremely helpful in coming up with ideas and how to structure these arguments. And so I don't know if you had a chance to browse through it. Yeah. So yeah, that's why I think I wanted people to understand AI is here to help. And I think that's how I feel. Is it a perfect technology? No technology is perfect. Even a thing like cell phone, people were worried if you use too much, you may have cancer and things like that. If you remember
Yeah.
that, right? Years down. I don't know where that research is now. So all technology has to be looked at carefully, but we need to exploit its advantages. And I do think AI will make things better.
Yeah. And when you ask the question, then can we trust AI? And you say things like AI is here to help. Are we at the point yet where we're really leaving that kind of decision making up to AI, or are we still kind of asking the question, can we trust humans? And I guess in other words, my question is, how much is the AI still bound to the limitations and behavioral value systems that the programmer has?
Yeah, yeah. That's a great question. There are four things we talk about when we think, can we trust AI? I think, I don't know, do you follow cricket?
No.
Okay, all right. Let me give you an example. Till a few years ago, the umpires made the decision and you can't question it. They say you're out, you're out. And you're not even supposed to throw your bat and do all the tantrums that we see in baseball because cricket, as you know, is a gentleman's game. Right?
Of
Now there is
course.
also a gentle ladies game. There are also women who play. Now, a few years ago, they brought in something known as DRS. Okay, that means there will be a ball tracker.
Mm.
All right. And there will be a microphone where the batsman is to see if the ball hit the bat and then it went and the catcher took it. Because sometimes the crowd is so noisy, the umpire cannot hear, and the catcher may just say, I got him, he's out. So now they can go back and listen to the microphone. And so the umpire can still make a decision and it can be appealed. And all of these technologies will come and it will show. And there are cases whether the umpire decision can be overruled or not. So to me, DRS is helping the umpire. And sometimes it can overrule the umpire because umpires can make incorrect decisions. So AI is a technology that can sit next to you
Mm-hmm.
and kind of look at the data and so on, kind of tell you, I think this is what is going on, and the humans have to be the final arbiter of the decisions. I won't take the DRS technology too much into AI where the AI can overrule the umpire. I won't do that because when domain knowledge is involved, people with experience are important, right? Doctors, for example.
Mm-hmm.
So human AI interaction is where the next progress has to be. So we can appreciate what AI is proposing and whether it makes sense in our current context. And then we jointly make the decision. That's the way to go.
So do you think that that will dominate for a long time into the future, that paradigm, or until maybe something like artificial general intelligence where
Yeah.
humans and AIs will work together until AIs become so intelligent that they're basically super intelligent?
As a technology person, as a person who guides the design of algorithms and so on, I'm always fascinated about that potential. But let's just take a simple example as an autonomous car. You think we're going to have a 100% totally autonomous car that works everywhere in the world,
I don't know.
right? What works in Phoenix may not work in Hong Kong or in London. In London, they even drive the wrong way, I think, like in India. So all I'm saying is, for this to have a general intelligence, right? The performance has to be so good under all circumstances. Humans have common sense reasoning, which we're kind of pre-wired in sense. There are some conditions that even when we are kids, we may not be comfortable with. And, we sense that, and so on. That common sense reasoning is a big thingy because it has evolved for us for how many generations and so forth. And sometimes we can't even explain, how we react, and we just react because there is this tendency to survive, to get out of danger, to be able to do and so forth. And we can rush. So to me, that the general AI is a concept
Mm-hmm.
that we should strive towards, like we want 100% autonomous car. But In trying to get the 100% autonomous car, we have made significant progress. The lane changing warnings. The car tells you if you're going to hit the car in front of you. When you reverse, the cameras come, they can even put box if a human is walking across. If you change lanes without giving the turn signal, it brings you back because it knows, no, you can't do it. So those are very important features which came about because we wanted the fully autonomous car so that we can cook a pizza in the car and and still drive. So that is what I will say. The reason, the goal of trying to get general AI is a good goal. And to achieve that, we will make enough of a progress. Even if you're 90% there, it's going to significantly help us with what we have to do. And as you know, as they say, right, if you shoot for the stars, you land in the moon. And we did land on the moon. I don't know if there was a goal to go to the stars. So that's how I see these things. But for people who like to predict where the technology is going and so on, this idea that, oh, this all purpose, all intelligent AI, and then immediately it raises the question of, gee, what it would be, I mean, I like reading about those things, but I'm a pragmatic person. I have to build algorithms. If I try the all-purpose general intelligence AI, I think I would be retiring and then it won't be there. So, yeah, we have to make small steps.
Yeah. And along the way, what do you think about the transparency of these algorithms that we're talking about? Because one of the big concerns, obviously, is the black box issue in
Oh, yeah.
AI.
Yeah.
So I mean, do you think we're going to see an increase in transparency, or do you think we'll just trust AI more to be making the right decision inside the black box?
Right. Everybody uses a TV. A good number of people don't know how it works, but they're quite happy because they turn it on. They see the sports, they see the news, they see the comedy scenes. But AI is not that simple. Because TV doesn't make decisions as to what you should eat. Maybe one of these days it'll do. I don't know. But all I'm saying is interpretability is extremely important. Transparency is very important. This black box idea is there with deep learning in particular, but I like to say AI was interpretable before deep learning came. Take about decision trees, even k-nearest neighbor rule, Bayesian hierarchical models, where we explicitly model the causal relationships between these things and throw probabilities on them, do inference on them. They're all interpretable, right? Now, when you come to AI, we have some ways of figuring out which layer of the deep network is contributing to the decision so we can understand that. More importantly, if you give me an AI algorithm, I can go and probe it and find where it creates problems, where it has, and then I can fix it. Things like adversarial training and other kinds of methods. So let me ask you this question. When people ask me this, I said, with AI, it's an algorithm. As you know, Stephen, an algorithm, when you give the same input, it gives the same output. It cannot give a different output, right? It's a set of rules. If you give a human the same conditions, depending on their mood, depending on how good the day was, the bad was, they're going to probably, not all of it, but it can happen. But do we know how to measure how humans make decisions? This is not to punt the question. But this is a question that we have to ask. Who are you comparing with? When you have an AI algorithm, whether it is transparent and a human making a decision, I can probe an AI algorithm. But with humans, I have no idea. So I would like us to understand that AI is a set of complicated rules, and we should strive. So transparency here means we should be able to say when it has issues. For example, all the drugs that are approved by FDA. But when you listen to their commercials, sometimes the side reactions they create looks worse than the original disease. But they have to be transparent. But still there is no guarantee that there will be a certain number of people who won't be affected by the drug in an intended way. because you can't test every drug on 8 billion people, right? Soon the world is going to be 8 billion. You can't trust. So you do your best and then you caution.
So it sounds like you're basically suggesting that we just accept that life has chaos and limitations, and that's going to happen in everything, including AI. So we shouldn't be unfairly harsh to our judgment of AI.
That's right. For example, every year, several thousands of people die in car accidents because various issues. But the moment one autonomous car and knocks off some, a cat, no, I don't. I mean, I like all animals, so I don't want to use any
Yeah.
animal that I think can be hurt. Something happened, or it hits a
Mhm.
lamppost.
Mhm.
My God, we get all worried, right? So I think that's where the we have to be. I think is getting better.
Mhm.
Technology does get better, and so on. So we have to give some time for the technology to be fully developed, and it will continue to develop and get better.
And on the subject, I guess, of self-driving cars, you've done a lot of talk about that. Obviously, computer vision was, a huge part of the self-driving car movement. Can you talk a little bit about maybe the future of self-driving cars and where that's at, where you think it's going?
Yeah, I think the idea for self-driving car came about one of my mentors,
Hmm.
Professor Asriel Rosenfeld. I still remember in the early 80s, he was kind of imagining, what if we just put some cameras on a car and make the car run around the campus? It was called Autonomous Land Vehicle Project. DARPA started it in 1985. I started getting interested in the early 90s, unmanned ground vehicles, bulky DOD kind of vehicles with big sensors and so on. I just want to give a little bit of history.
Hmm.
So in those days, we will have inertial units in the car, because we thought if we know where the car is exactly, and then we can combine it with video images and do better processing. Every time we tried that, it will blow some fuse. So, now we know exactly where we are, right? In
Hmm.
GPS. So this is how it started. And we had bulky radars and all that stuff. Now I think, Tesla is everywhere. Tesla is just done using just video information. And Waymo, I believe, does LiDAR, 3D information and so on. I think still, I don't want a Tesla, and people are surprised because I've been working on it for some time. I think it'll get better. It'll have more functionalities. But what is now going to probably happen, if you have a heterogeneous sort of situation, some Tesla with automatic skills, and then somebody like me like to drive the old-fashioned way, how are we going to interact
Hmm.
when we are driving? Just like the human. Now, what you can think is machine is Tesla and my car is human, because it's driven by a human.
Hmm.
So we are coming back to the same old problem of human AI interaction. So you should not view Tesla when it is fully automated as a car. It's an AI system. It has its own way of doing things. And then I am driving my, car with the gas powered and it's not automated. I am a human. So
Hmm.
the same situation comes. But the interesting thing here is everything is instantaneous. If I am driving at 65 miles on the freeway and the Tesla is going at 70 miles and there are some other Teslas and I'm there, it's a very highly dynamic thing. So how we all interact with each other. So there is at a global, I mean, looking back, everything looks very stable and safe.
Hmm.
Locally, it's like Brownian motion, not quiet, right? You can't do a Brownian motion on freeways. The cop will give you a ticket. You got to follow the rules. But if you do these two kinds of, AI is the Tesla and I'm the human, dynamically how we interchange cross lanes and make sure we are safe. There was a project even in the mid 80s in UC Berkeley called, Caltrans and UC Berkeley called PATH, I think, where the idea was to put sensors on the road and have the
Hmm.
sensors help the car, be on a convoy and follow each other and so on. I think now we are depending more on the sensors on the car because it's a lot of work to dig up I-95, and or 495, 405 to put these sensors and so forth. So
Yeah.
we're believing on the sensor, but every car has to know where it is with respect to everything else, where the world is, so that ideally they can all go like the race car thing. You see that? I mean, they're like, it looks like they're 2 feet. They're separated just by 2 feet, and they're all going at like 300 miles an hour. I said, oh my
Yeah.
God. But of course, when things don't go right, I mean, it's catastrophic. But you see how closely they follow, and humans are doing that. So if we really become very automated and everything is, they can just go at like 6 inch separated. But then wow, that'll be a joyride. Well, maybe
Yeah.
not for me. So that is where I think. And can this be done over a period of time, or one day we all say that's it? It's all AI
Mm.
cars now. That transition, because you have to now think about the people, how many of them signing up to it, what are the issues and the challenges and so on. So I think it's eventually going to get better. Maybe there will be some applications where like I've seen even trucks, 18-wheelers on their own. Okay,
Yeah.
I've seen demos of that, and then they say it cannot go inside the city. It's going to come somewhere off ramp. I say fine, and then I got to grab everything from on that truck and put in little trucks and then take it inside. It doesn't look like a good engineering solution, because point to point is
Hmm.
what we wear automation. Anyway, so yeah, go ahead.
Yeah, I was gonna say it seems like it would be a hard transition to make to get to that fully automated path, I guess, just because if you have a person driving a car, having an AI car come up to you just 6 inches away, I don't know how you can make that switch without switching the whole thing at once. Like that
That's
looks
right.
like a recipe for disaster if you don't have
Exactly.
everybody doing AI at once.
Right. Yeah. Yeah. That's like, it's like, we all speak English. Tomorrow we all going to be speaking French. I said, yes.
Yeah.
Yeah, that's right. So, but it's a good thing to strive towards that,
Hmm.
because what will happen when you strive to, you're going to improve the networking technology, you're going to
Hmm.
improve the processor technology for this to be real time, and you will understand how tens and hundreds of dynamically moving things have to interact so that everybody gets to a place safely. I mean, those are all beautiful. You might have heard about the swarm issue, right? A lot
Yeah.
of planes flying. Biology does it. Haven't you seen hundreds of birds beautifully fly, and suddenly the leader decides to take a left and they all go left? They all go right. So biology has figured it out, but it's a little more complicated for us.
Yeah, you just made me think of something with that statement. Biology has figured it out. Do you think that the direction that AI is going should be a replication of the human brain and how it functions, or do you think it's going to take an entirely different kind of intelligent route? You know what I mean? Like, are we going to
Yeah.
see it replicate human intelligence, or is it going to be a new form of intelligence?
Yeah. Oh, this question. This is a great question. This has been discussed for 60, 70 years. In
Mm.
fact, there's an old book I read. I forget who wrote it. They said if you have to design an electronic system like a human brain, they were talking about vacuum tubes. So you can dare it. They said that will be as big as the Empire State Building, and then it will require Niagara Falls to cool it. Right? Of course, our brain is like so efficient in terms of how many watts it spends, and it makes all these decisions. There is a whole field, bio-inspired computing, neuromorphic computing, which has been developed in parallel to regular CPU, GPU based computing. Um, and I have many distinguished colleagues in my department at Johns Hopkins who have been pursuing this. It's again a noble goal. And then what it will do is help us how to optimize power consumption by these GPU clusters. If you see data centers, if you come to Ashburn, a neighborhood in Virginia, they're just huge buildings. They suddenly sprang up in the last 5 years. I said, what are these buildings? Data centers. They consume a lot of power, right? It actually is raising a green AI as a new uh, discipline. If that kind of power had to be spent by our brain, I think our brain would have melted into fluid long time ago.
Yeah.
So there is a proof of existence
Yeah.
that complicated decisions can be made by integrating our sensing with computing, with reasoning, and all of that with the most efficient way. Now, should we try to replicate that? Somebody would say, yes, somebody would say, or should we be inspired by it? I want to be inspired by it because we can do experiments with how we perceive things and how we compute things and so forth. So some would argue the neural network, the hierarchical architecture itself is somewhat, not exactly what, but hierarchy is important in visual processing. So we have these deep networks and nonlinear is very important, processing the neurons nonlinear. So we do have ReLU and we do have sigmoid nonlinear functions in neural networks. My advisor, again, mentor, Professor Rosenfeld, used to say signal processing will help computer vision only it stops being linear and Gaussian and so on. So those are the good inspirations we derive. And the study of brain is a lifetime endeavor. So definitely, I would go with bio-inspired computing of AI, definitely, because great advances, less power, more generalization, and able to handle surprises, those sorts of things.
And while we're on the topic of biology, a lot of what you talk about as well obviously deals with the artificial intelligence impact in the medical industry and diagnosing and things like this. Could you maybe talk a little bit about what's happening in that realm? Because I know it's a very robust realm, but I would just love anything that you can share.
This is what I like to say. You need 1001 AIs for medicine. Well, look at how medicine is practiced. Is there one doctor for everything? Well, the doctor is family practice, internal medicine doctor, but then you have all these specialties. So AI would be able to be structured like that. I don't think we have to exactly mimic, but we may have to look at it that way for the simple reason every disease has a domain knowledge that goes with it. That's why we have the specialties, and every disease has certain kinds of data that goes with it that people look at. But there are the common data like your vitals, your more, high level things that are common for everything. And some inferences can be drawn from there, right? But then once you become specific to a particular thing, it has to be a different data, different domain knowledge, different way of diagnosing it. So that's why I'm telling my doctors, friends, I think one AI is not going to cut it. We need 1001 AI. Says, why 1001? I said, I like that number. I don't know if there are that many specialities. I'm not sure. Obviously, what works for one type of cancer is not going to work for the other type of. Even within cancer, there are differences. So I think where we are right now, domain knowledge is still there in medicine. That if you don't believe that, then you are telling you don't need doctors. That's not going to happen. Now the doctors are going to be helped by mining other data, electronic health record, diagnostic images, previous visits, everything being more and more quantitative. At Hopkins, we have what is called PMAP, Precision Medical Medicine Analytic Platform, where all the data can be kept, and then you can run your AI algorithms on that. As you know, medical data is very heterogeneous, right? Blood report comes with numbers, and then images come, and then you have conversations, natural language conversation between the doctor and the patient. So how do you multimodal AI is becoming very important. The other issues we have is let's take pathology for example. Every labs have different procedures. Many labs, it's like every microscope you have to view it as every camera. Cameras are different, how they collect data, how they quality of data, and all of that. So likewise in pathology, a sample from one lab will look different from a sample from the other lab. Even subtle changes. Same thing, but the process is slightly different. So if I train using pathology lab A, will it work in pathology lab B samples? Will AI be universal? So that is something we are looking at. The last point I want to make in medicine is the interactions among doctor, physician, patient, and AI. AI is now sitting, you have to imagine AI as sitting next to the doctor.
Mm-hmm.
Okay. You might have seen the movie Beautiful Mind. I don't know.
Hmm.
Remember, there is one guy that shows up who seems to haunt the Nash. You know, AI is going to be like that. And so now you have to understand the interactions among the three. A patient may trust you as a doctor. I think based on this is what we have to do. But now you say, my AI buddy is saying, then the patient says, how do you know? Your buddy knows. Buddy didn't go to medical school, buddy didn't do MCAT, buddy didn't do residency. Trust factor again. And
Hmm.
so there the doctor provides confidence that, yeah, I know what this guy says and I'm comfortable with it, but I think this is a good decision. So those are all the things that are going to come into play.
What about the ethics and accountability in the medical space? Because I studied computer science at university, and one of the things that we were talked about was this case where there was a form that basically determined how much radiation was given to a cancer patient. And there was a bug in the code for the form that if you highlighted and deleted rather than just hitting backspace, and deleting, it would leave the previous numbers there. So whatever you entered would be appended or added to the number. So instead of 30 units of radiation, the patient would get 3,030 units of radiation. Who's accountable in such a situation? How do we, in the realm of engineering, if you build a bridge, there's a lot of things you have to go through to make sure that you can build that bridge. But
Yeah.
there's a lot of programmers in the medical field who just can write code and send out software, and there's no accountability, no licensing. How do we navigate that ethics and accountability as the AI becomes more advanced?
It has to be, regulated in some sense. Accountable. Accountability is very important. And
Mm-hmm.
technology that does not do good for everybody it's applied to is not going to be accepted. There will be consequences. Now, the particular thing that you mentioned, I have to probably say it probably happened before AI came, because it seems
For
to be
sure.
a
Yes.
right. It seems to be a
Yes.
programming issue and software issue. You know what happened with 737,
Mm.
the most recent Boeing, when Boeing is world's best builder of aircraft. And what
Mm-hmm.
happened there? There was some sensor issue, and the pilots did not know how to handle that. And a few of them, the Max plane, right? And this day and age, despite Boeing building these things going back to 1970s. So 1970, I think, is when the first 747 came or something like that. You can check it up. So all I'm saying is it's a complex system, right? In Boeing, but Boeing is accountable. National NSTB came and FAA came and said, come on, guys, they grounded it. And
Mm-hmm.
Boeing took a big, big hit. And there was some conversation how this happened. Well, from what I can remember is the FAA was actually letting Boeing, come up with its own certifications and so forth.
Mm.
Now, so I think, we have to look at that if that was the right thing to do and so forth. But it was fixed. I'm actually taking a 737, that aircraft back from California to Washington, D.C. I won't think much about this particular. If the plane jerks a little bit, oh, maybe there's a software issue
Bad
again.
sensor.
Yeah, you know. So the example you gave is before AI, and with
Mm-hmm.
AI coming in, there's more of those things that can happen, and so forth. So there has to be, when FDA approved this many software for AI into medicine. I hope somebody is really looking at it. But look at it this way, Stephen. Even the non-AI prescription medications, like we talked before, right? Does it help
Mm-hmm.
everybody? No. Tylenol, you remember Tylenol issue, but that was a bad guy doing something. But even medicine, for some people, the reactions are different, right? So what happens there? Immediately you recall, or you make sure that particular if you look at all the advertisements, it'll say, if you're having this problem, that problem, that problem, that problem, please do not use this. That's accountability, because they
Mm-hmm.
have done that. So we have to, like I told you before, if it rains, don't use my vehicle detection algorithm. I declared it.
Mm-hmm.
You know why? I know the user is going to use that. So if it rains, he's going to come back, Rama, it's not working. What should I do? So I say, okay, I will declare upfront, don't use it. When this happens, that happens. So they trust the software, right? So the only issue comes when you don't when the users are just thrown some software updates. For example, we give updates for our software, various software. There's sometimes that will mess up something you have. They may not tell you. They just, updates keep coming. I don't know. Sometimes these updates are good or bad. And
Yeah.
half the time, I don't want to even respond. I ask somebody knows. They say, oh, that's okay. Because you worry through the update, maybe you will have some kind of a virus that comes
Yeah.
and wipes out your laptop. So there also, you have to trust, the brand name and, so forth. So to cut the story short, accountability is extremely important. But there is a limit. One cannot spend the entire space of things that could go wrong. But
Sure.
most things. But if there is a failure, there must be a place immediately to grab it, fix it, and then put it out.
Yeah, and this feels like it gets to one of the big topics of the book as well, which is, your point that we're still in the very early phases of AI and our regulatory systems simply haven't caught up yet.
Yeah, yeah.
So can you maybe talk about some of the concerns you have where maybe things need to be more regulated, or maybe some of the regulations that you would just like to see happen in the future?
Yeah, sure. I think anything has to do with, I'm also a professor in School of Medicine at
Hmm.
Hopkins in biomedical engineering department. Anything that goes with AI and medicine has to go through the rigorous evaluations that FDA does for regular medicines, except this is software. So they have to have the right type of people who understands. And this is becoming an issue not only in health, but also in Department of Defense and others, is getting the right workforce, knowledgeable workforce. For example, if I an AI company building a system for US Navy or Air Force, I say, hey, this is a very intelligent system, it's going to do X, Y, and Z. Somebody on the receiving side should be able to check it out and put a stamp of approval. Right. So that's important. Or no, so regulation, accountability, they are all kind of coming together. So there are so in health, it's obvious. Anything to do with people's health, it has to be regulated, just like FDA, AI. I would say likewise in smart cars. There are Tesla and other cars. There's sometime anything something happens, and NTSB gets involved. They want to understand why it's happening. So a car has to be certified. That it is safe to drive, and most cars, as we know, are safe to drive. They don't just fall apart. The tires don't come off the thing and so on. So definitely we need to have people who are knowledgeable about the functioning of AI systems under adversarial conditions. As you know, there is another issue we talk about AI. Can you hack a AI system and make it do, the other things? You want to go left, but it decides to go right. Sure. So we are working on those problems too. So that is what we need. We need regulations in every aspect of AI that controls or that has something to do with our lives, day-to-day lives. Now, those will be different for different segments. Now, and so that is basically, it's not one set of rules. Uh, but if you really want to have one set of rules, it will become very general. For example, AI should work everywhere. Now, tell me, how do I define that? Right? Okay,
Yeah.
that's what you want. I want Tesla to go to work in Bombay and Mumbai and Hong Kong and London and Phoenix and Indiana. Okay, what does it mean? But you have to provide constraints for it, because that product will be so simple. Sometimes they say if you are risk averse, you have to, this lowest common denominator kind of an argument, right? It has to be very, very simple. So you're not going to fully realize the benefits of AI. So it's a company that developed the AI, and ethicist. There's a big field. A lot of people from bioethics kind of are contributing to AI ethics. We have Berman Institute at Hopkins, a lot of researchers looking at AI ethics issues, ethical data collection, ethical loss functions, because we use them to train AI. When it, do we tell people when it won't work, when it works, as a good faith, argument, and so on. So I say, right, it's regulations. If you look at our political thing, regulations are considered to be bad. So even if you take the two major parties, right? One party is kind of looks like they want to regulate and make things safe. The other party is, oh, that kills business. Small business cannot do this. Even simple paperwork. They say, oh, they have, So we have to kind of face that too, right? So
Yeah. Yeah. Are you concerned about thinking there of like the government and technology? It makes me think of, governments using AI to use facial recognition, psychological profile building,
mm,
surveillance capitalism, etc. And I think a lot of people are concerned about this idea that, in the sense that Cambridge Analytica seem to kind of manipulate the public opinion, that these tools are going to be used against us. Are you concerned about things like this with facial recognition and surveillance capitalism?
definitely I'm concerned because, as I say, a technology that doesn't work for all is not going to be good. And
Mm-hmm.
we do know from the 2018 MIT work, you may be familiar with the Tinmit Kabru's work and his co-author,
Mm-hmm.
when they tried gender classification, it didn't work well for dark-skinned males and females, and it worked well for lighter, and that raised alarm, you know. So
Mm-hmm.
immediately companies have to react. Some pulled out their software, some improved their software, and so on. We built system, and we were concerned that is this happening to us? But we have a method to probe our system to see where the bias is and how much it is. So I have a couple of papers on that. I'm happy to send them to you. We saw that our work, our system, the Janus system, for example, showed bias to skin tone, bias to gender. So we then developed methods using adversarial training, knowledge distillation to reduce, to mitigate bias. The two approaches. You throw everything, start afresh. There's no guarantee that when you do that, you are going to have the high performing network like you had before. So we said, let's take the best performance system and reduce the bias. So with AI, I'm able to do that. Okay. So you give me a system, I will know what it may be sensitive to. Then I can go and probe how sensitive are you to this factor? How sensitive are you to that factor? Ethnicity, skin tone, age, gender. Okay. And then I can improve it. Am I going to have a zero bias? Can I tell you? If you don't want to make any errors at all, then you don't make any decision. She said, well, that is how decision theory works. I'm afraid to make error. So zero bias, it may not be a performance system. Now, how much bias you want to accommodate? But at least if I come and tell you, my system has this much of bias. So when it makes a decision, the final human educator knows to take it or leave it and make his or her own decision. So that is how if it is done this way, people's concerns will be assuaged. They'll say, okay, so there's somebody here. So I think this is happening, not just my group, other groups are working on this. So fairness in AI using optimization approaches, using adversarial learning, adversarial training, and so on is a very active area. There's even a conference called FAT, I think, which does these sorts of things. So I'm going to I like to ask people who ask me questions, ask a question. I can quantify AI bias. Do you think we have metrics for quantifying human bias?
No,
Yeah.
no, not at
I,
all.
Again, this is not to punt. As I said, you can't answer a question with a question.
Mm-hmm.
But I did answer your question to some extent, so I think I
Yeah.
can ask the question. We don't know. We
Yeah, I mean
don't.
it's a good point. I mean, like you're saying, at least AI, a lot of the issues that we're concerned about AI is the same issues we're concerned about with humans, but at least in the case of AI, we usually have data to understand it. Whereas with humans, it's a true black box and we could just be lied to very clearly. So I mean, it's a great point.
I'm going to pick up on what you just said. My
Yeah.
catchy thing is AI does not lie. Humans may.
Yeah.
I don't say humans do. That assumes every humans die. All no, that's not true. AI does not lie. Humans may.
Fair enough. Well, Rama, we're coming up on our time here, and I want to respect yours. I know that you got a lot going on, but I'd like to give you a moment to obviously give us some closing thoughts. Maybe tell us a little bit more about the book, or share anything you'd like to
Yeah,
tell people.
yeah, sure. I like to encourage the readers to read the book, cover to cover.
Mm-hmm.
And hopefully we answered, we are providing some assurances for how AI can better their lives. And hopefully we have given them some comforting arguments that they don't have fears about new technology. Every new technology brings in certain concerns. When steam engine was introduced, they thought the cows may not give milk anymore. When they're by the track, there are all these stories. So they should not be concerned. And the best way to be not too concerned is to know about it, right? If you don't know about it, then you're going to believe what people say and get worried. Just go and take a book. It doesn't have to be my book. I hope it is my book, but go and take a book and read. There are a lot of fantastic books on AI, depending on like somebody like you as an undergraduate computer science, a book by Stuart Russell and Peter Norvig, fourth edition, is an amazing book. I use it for my class. It's a great book, beautiful book. And and they have updated the fourth edition with deep learning and other things. That's what I will tell everybody. Just read, be informed. Knowledge is power. And knowledge will dispel ignorance, knowledge will dispel myth. So to me, this is what I'm worried. Students are saying, "Oh, who reads books these days?" I say, "Oh, don't tell me that. I'm a professor. You have to read books." And I love books. Yeah, there you go. I tell them books are my great friends. I talk to them. They don't talk back to me. And so I think knowledge is what will dispel these things. However much I can say. And so they should read chapter 5, where we are very optimistic about AI, how it can be used for disaster relief, how it can be used for climate change related issues. Climate change is real, and those sorts of things. And even in chapter 2, we have a great example of one of my colleagues' work, Suchi Saria, how she's able to help sepsis case and so forth. So you're seeing more and more of this example. So AI is going to be your friend. It's going to be there to help you and so on. And I think it's going to be okay. So that's what I'll tell
Yeah,
them.
I love it. I love that optimistic note, Rama. Again, thank you so much for your time.
Yeah, you are welcome, Stephen. Have a great day.